All right. I'm going to do these in groups of 3. So I'm going to try and do like one of each kind. So this first one is a 4 plus 3 cosine of theta. I'm going to go to my y. Remember, we already changed our settings on here. I'm going to go to my y equals and type in 4 plus 3 cosine of theta. One more thing I'm going to do under window. Right now, it's going to implement the points from 0 to 2 pi. Now, remember with these that you can keep on going, that the 0.13 is not the same. You can have infinitely many. And so these graphs will actually keep on going forever. So the calculator only plots a limited number. It only goes from 0 to 2 pi. So right now what I'm going to do is change this to 3 pi so that it'll go a little bit past just in case. Okay. So there's my graph. And I'm going to go, I'm on probably some weird screen, so I'm just going to go to Zoom Standard for right now just to see what this looks like. And actually, I'm going to go back and go to Zoom Square is where I want. That'll be better. And you'll be able to see the symmetry better. So, obviously not a circle. Okay. It's a limicon. So what kind of limicon is it? So if you look in the book, you have the 2 that have cosine. Okay. So it's either a cardioid or it's a dimpled limicon. So this right here is A, and this right here is the opposite of B, okay? And so with this one, they did A minus B. It can be A plus B. It's actually either way. A is 4, B is 3. So 3 is less than 4 is less than 2 times 3 is 6. So that fits. And so we know that this is a dimpled limicon. So I'm just going to write that down off to the side. And if you don't put the funky thing on the bottom of the C, I don't care. I'm not gonna, that's totally fine. Okay. So graphing this, how do we get this from here to here accurately? Now remember, under the window, I said pi 12ths. So each one of these lines is what's going to be represented in my table. So I go to my table and I had already scrolled, so I'm going to go back to 0. So my first one is 0, 7. So 0, 7 is right here, okay? Now this is pi 12ths, which is here, and I'm at 6.9. This is pi 6th, I'm at 6.6. This is, let's see, pi 4ths. This is at 6.1. And you don't have to know what fraction this is. You can literally count. This is the next line. My next line is at 5.5. My next line, pi halves, or sorry, 1.3 is at 4.7. I almost goofed up already. And that's why it's good to know that this is pi halves. And so at pi halves, I should be at 1, 2, 3, 4. Okay. And once you start to get these, there's some where, yes, you're going to want to go and graph every single point on every single line. And there's some where they're going to be so close together and there's not going to be much change where you can skip. So now next, I'm going to be at 3.2. Then I'm going to be at 2.5, 1.8, 1.4, 1.1, and 1. At pi, I'm at 1. And it's a symmetrical graph. So if you're really good with symmetry, you can graph the rest of those, or you can just keep on going. So this is going to be at 1.1, and then at 1.4, 1.8, 2.5, 3.2, 4. There's my 3 pi halves, 4.7. And then I'm at 4.7, 5.5, 6.1, 6.5, 6.9, and then I'm back to 7, and then it's going to repeat itself, okay? And I cut myself really bad. So I'm actually in a lot of pain on the back of my hand. I don't know if you can see this nice anything. Anyway, and so my writing is not the greatest right now, but I'm doing the best I can. So, all right. Next one. Go back to my R equals, and I have 2 plus 2 sine of theta. Like the theta button is the same as your X button. If I look at my graph, okay, this one is not a circle. Again, if you're on the Zoom square, you'll be able to tell that it's a perfect circle. This is another limicon. And if you look at this one, my A and B are equal to each other. So this is an example of a cardioid. So it's going to be pretty tiny, and so this is one where I might be able to skip lines, but you just got to count correctly. So I can go to my table. I always go back to 0. And then plot my points. So 0, 2, and then the next line I'm at 2.5, 3, 3.4, 3.7, 3.9, and 4. It's going to be symmetrical. So we're going to go back down, and we'll be at 3.9, 3.7, 3.4, 3, 2.5, and 2. There is my pi. And now something different is going to happen down here. So this is at 1.4, 1. And this is where it gets kind of sticky. I'm at 0.5, 0.2, 0.06, and then at 3 pi halves, I'm at 0. Then I'm at, again, because it's symmetrical, 0.06 on this line, 0.26. I'm not even going to plot those. On this line, I'm at 0.5. And then I'm at 1. And then I'm at 1.4. And then back at 2. And it makes kind of a little point and looks like a heart. Okay. All right, next one, no sine or cosine. Boom, we know it's going to be the spiral of Archimedes. This is one where underneath the window, I had changed this. What did I change? I thought I had changed this. Oh, because I went back and I did Zoom Standard. So you can change this to something different. Watch what happens. The spiral of Archimedes keeps on going forever. This is the only one that's going to have an arrow on it. So I'm going to type in 2 theta and I'm going to graph it. It looks like it stops. It doesn't stop. It actually keeps on going. Okay? The only thing I ask of you is that you fill the graph that you have. Okay, most of your graphs go out to 4, 5, 6, somewhere in there. Go out to the edge of the graph and then call it good. Okay, or if you make more than one complete rotation, you can stop after that. If it's a super tiny little curve, as long as you go through from 0 to 2 pi, and you're good. I won't have you do more than that. But doing just this little tiny piece, that's not enough for spiral of Archimedes. If I want it to go further, under my window, my theta max, I'm going to change that to 3 pi. And I had done this earlier, but it got changed back. Notice now it'll keep on going. Okay. So under my table, I'm always going to start back at 0. So 0, 0. This is going to be awfully tight. So I'm at 0.5. And now this graph that I have is going by 5s. Okay. You can go by a different increment if you need to. And then I'm at 1. I'm at 1.5. I'm at 2. I'm at 2.6, which is about halfway. And then I'm at, notice this, at pi halves, it's actually at pi. So I'm at about 3. .6, 4.1, 4.7, 5.2, so it's going to cross that line on my paper, 5.7, and then at pi I am at 6.2, 6.8, 7.3, just shy of halfway, 7.8, 8.3, 8.9. At 3 pi halves, I'm at 9.4, and then 9.9, 10.4, 11.5, 12, 12.5, and then at 2 pi, I'm at, so as I made one complete revolution, I am going to stop there. At, this would be 6.5, would be 13 if I wanted to do one more. I'm not quite halfway. No, 13, just kidding, 13 would be halfway. Silly me. Over halfway. And these have to have an arrow on the end. These are the only graphs that have an arrow.